Yeah, good day to you all. And in this lecture, we are going to see about different application and domain-specific embedded system concepts. Here we can say we are going to take two examples in this case. The first one is actually the washing machine. I think everybody knows about a washing machine. It's an application-specific embedded system, right? And washing machine, it's a typical example of an embedded system, and it contains different sensors, actuators, control units, and application-specific user interfaces like keyboards, right? Everybody will be having a having a washing machine in your home, and how this washing machine can be controlled, right? That actually we are going to see here. So this is actually the diagram of a washing machine, how the system works. There's going to be a level sensor. Right, on the left hand side you can see there is a level sensor, and this level sensor is actually useful for maintaining the water level, right, in the drum, right. And the second one is actually the water inlet pump, in which I can pour the water into the washing machine, right. From the tap the water will be coming inside. Then we'll be having an inner tub, then I'll be having an outer tub, then there's going to be a water outlet, so that the water should be drained. So in that case there is a water outlet is there. And there is a body case, right? Again there is a body case, and then I'll be having an integrated control panel with the user interface, so that the user can give some inputs. And what are the sensors available? One is actually the level sensor, and the second one is the temperature sensor. Two sensors are placed there. And on the keyboard there should be a proper user interface, and for user interface you can see there are two things. One is actually a keyboard where I can set the time, like 30 minutes or 1 hour or 2 hours, whatever it is. What should be the washing time? I can set it. Then the second one is what operation we are going to do that, right? So whether we are going to wash it, or we are going to soak it, or we are going to rinse it, right? So what is actually the activity? And the third one is light, warm, light, medium, and heavy. How much of cloth I will going to put it? Suppose if I am going to put some minimum cloth, then I can say it's a light operation. If I am putting the maximum amount of cloth, right, say for example 6.5 kg washing machine and I have filled the maximum cloths, then my operation is going to be heavy. Then there's actually a start button. So this is actually a normal keyboard, keypad, in order to control my washing machine. And there will be a LED display. Most probably this LED display will be giving an idea about how much time is remaining in order to complete that particular washing. And we will see just one by one. The actuator part of the washing machine consists of a motorized agitator, a tumble tub, and a water drawing pump, and the inlet valve to control the flow of water into the unit. And the sensor part, again there are two sensors are used. One is actually a temperature sensor, the other one is level sensor, even though now plenty of sensors are actually used, right. Say for example, if there is no washing powder, all right, again the system will not work. Then there will be a sensor whether your door is properly locked. Suppose if you during the operation, if you open the train to open the door, then immediately my washing machine will stop. So there are plenty of sensors are used, of course. So for example, they have given a temperature sensor and a level sensor. And as a controller, whether we can go use a microprocessor or microcontroller. And normally the sensor data will be given to the control unit, and the control unit decides what action should be done, and based on that it will generate and give necessary instructions to the actuator outputs. And the control unit also provides connectivity to the user interface. It also takes the inputs from the user. Say for example, how much time I have to wash, how much load that has been given, right, and all those inputs it takes from the user. And again washing time, how long I have to wash it, and all those things. And user feedback is reflected through a small display unit. So whatever price I can see a small 7-segment LED display that can be used in that. And again there are two types of washing machine. One is actually a top loading washing machine and a front loading washing machine. Again, for example, in a front loading washing machine, suppose if the door is not closed, then it should not operate. In the top load, again that will not be a problem because it is going to be in the top. So even if my door is opened, there may not be any problem again, right? But in the case of front loading, it is not the same case. So there should be a proper sensor whether my door is properly closed or not. Again, there are some differences, of course, based on the type of embedded system we can say. And one is actually the top loading and the front loading is there. And in top loading models, the agitator of the machine twists back and forth, right? We are discussing about the top loading. So back and forth, it will rotate for some time in clockwise direction. It will rotate sometimes in the anti-clockwise direction, right? So this particular action will try to pull the cloth from which is actually floating on the top of the water level into that, so that I will be making a proper washing, right? And in the front loading washing machine, the clothes are tumbled, so there is going to be a rotating drum so that the clothes are tumbled and plunged into the water over again and again, right? So this process is actually called as washing. And in the second phase of washing, the water is pumped out, so the old water which is having all those dirt particles while washing will be coming out. And there will be, of course, the tub uses a centrifugal force, right? So in this case, actually what happens, that inner cylinder, we can say, will be rotating at a faster speed, and because of the centrifugal force, the water will be extracted out from the cloth and will be moving away, right? And this is called the spin phase. And the inner tub of the machine contains a number of holes, right? So that will be having so many holes so that the water will be going off, and almost the cloths are free of water, right? That is actually the case. And the design of washing machines may vary from manufacturer to manufacturer, but this is actually the basic underlying principle. There may be some minor variations in the shape and all those things, right? And the basic control consists of a timer, cycle selector mechanism, water temperature, load size, and a start button, right? Already we have seen this. And what about the mechanical things that are available in a washing machine? Most probably it will be a motor, right? So which converts an electrical energy into mechanical energy so that I can have a rotation of the tub. And transmission, they should be transmitted either through a belt or something like that. And there should be some clutches, there should be a pump and agitator, inner tub, outer tub, and water inlet valve. So see, these are all the mechanisms that are available there. And the water inlet valve connects to the water supply line using at home and regulates the flow of the water supply into the tub. I think you should be knowing it. And this can be called as an integrated control panel, right? So this is again a typical washing machine, and what are the user interfaces that is available. You can just see what are the different buttons, right? Push buttons, touch buttons that are available on the washing machine. And also you can see the LED display or the 7-segment LED display, and so many small LEDs which will give what is the status of the working washing machine. Right, and the integrated control panel consisting of a microprocessor, microcontroller, already we discussed. Input interface includes the keypad interface, right? Already we discussed. It contains of LED, or nowadays actually it can have LCD also. And the other type of IOs which are invisible to the end user are different kinds of sensor interfaces, namely water temperature, water level sensor, etc., and actuator interfacing for agitator and tub movement control. And inlet water control and all those things. Fine. So I think here we have discussed what is a washing machine, what are the sensors used, what is the general operation process, and what are the sensors and control signals that are available. Right. Now we will get into the second application. The second application is actually the automotive domain. And in the automotive domain, we can take a single car, right? So what are the possible sensors that can be placed inside the car, and how effective these embedded systems for the user-friendly operation of the car, right? So we are getting into the second thing that is called automotive, right? Now here actually we can see there is a car, and what are the possible sensors that can be placed inside the car. So there will be panel instrumentation, right? So there will be the dashboard will be there, where you can see the advanced cars will be having what is the speed, what is the trip, right? How long we have traveled, what is the total trip, right, from the starting point, and then what will be the mileage, how much diesel or petrol is available in the tank. So your dashboard will be having so many informations. So everything comes under this control instrumentation. The second one is the engine control. Again, there is an MPFI, I think microprocessor based fuel injection. You might have heard about it. This is available in almost all the vehicles nowadays. And the engine should be controlled using a microcontroller. Then the fan control, right? So there will be initial fan in order to cool the system, cool the engine. So the speed